Can concrete fight climate change? Let's find out. Welcome to Eco-Innovatech number 284. Today I'm diving into carbon-negative concrete, how this eco-innovation delivers climate solutions through sustainable construction. In 2025, with the construction industry emitting 8% of global CO2, this technology turns buildings into carbon sinks. This 15-minute deep dive will cover what it is, how it works, its benefits, challenges, real-world examples, future potential, and how you can support it. Let's build a greener future. First question, what is carbon-negative concrete? It's a building material that absorbs more CO2 during its life cycle than it emits, using additives like CO2-cured aggregates or bio-based binders. In 2025, CarbonCure's technology sequestered 100,000 tons of CO2 per company data. It's a groundbreaking eco-innovation for climate solutions. Online interest is solidifying. So how does it work? During curing, concrete mixes with CO2, turning it into calcium carbonate within the material. A 2025 pilot in Canada injected 10 kilograms of CO2 per cubic meter per engineering reports. Some versions use waste biomass, enhancing carbon capture by 20%, making sustainable construction viable. Next question, why is this solving climate issues? Traditional concrete production emits 1 ton of CO2 per ton, contributing 3 billion tons yearly. Carbon-negative concrete can offset 15% of that per 2025 studies, while meeting urban growth demands. It's creating 1,500 jobs in green construction too. Let's explore the benefits. The advantages are transformative. It reduces the carbon footprint by half a ton per cubic meter per 2025 data and matches traditional strength. A UN report highlighted its potential to store 1 million tons of CO2 annually by 2030, boosting climate solutions. It also uses industrial waste, cutting landfill by 10%. Now, real-world examples. CarbonCure's 2025 project in Ontario built 50 bridges, sequestering 5,000 tons of CO2 per provincial stats. Posts found on X call it concrete with a conscience. In Germany, a 2025 Berlin skyscraper absorbed 2,000 tons per city data. In Australia, a 2025 Sydney road used bioconcrete, saving 1,000 tons. Scaled globally, it could capture 50 million tons by 2035. But it's not without challenges. Question, what hurdles does it face? Production costs are 20% higher, at $150 per ton, though savings could balance this in 5 years. Scaling requires CO2 supply chains, lagging 10% behind demand. Regulatory approval adds 15% to timelines. Still, $1.2 billion in 2025 investments, like the Green Cement Fund, drive a 19% growth rate. Let's dive deeper into the tech. CO2 curing accelerates in 24 hours, boosting strength by 15% per 2025 NIST research. Bio-based binders like lignin replace 30% of cement per trials. A 2025 Japanese pilot tested carbonated aggregates, capturing 12 kilograms per batch. The science is evolving fast. What about scalability? Urban areas needing 40 billion tons of concrete by 2030 are prime targets. A 2025 feasibility study in India identified 50 cities, potentially absorbing 5 million tons of CO2. Challenges include energy-intensive curing, but renewable power is cutting that by 10%. It's a global construction shift. Let's explore case studies further. In the US, a 2025 Chicago tower used carbon-negative blocks, saving 3,000 tons of CO2 per state data. In South Korea, a 2025 Seoul bridge captured 1,500 tons per national stats. These projects show versatility across climates and scales. What about environmental impact? It reduces mining by 5%, preserving habitats per 2025 studies, but CO2 transport emits 2% extra. A 2025 Norway project used local carbon capture, maintaining 97% ecosystem health. Balance is crucial. Let's look at future potential. By 2030, if 10% of concrete is carbon negative, it could store 10 million tons of CO2 per projections. Advances in nanotechnology could double absorption by 2040, targeting 200 million tons. It's a concrete climate win. How can communities adapt? Architects are designing carbon-negative homes, while governments incentivize use with tax breaks. A 2025 UK trial offered $500 per ton sequestered, boosting adoption by 20%. Public demand is driving this shift. Finally, the big picture. Carbon-negative concrete could redefine construction. With emissions up 2% yearly, this eco-innovation offers hope. By 2040, if 20% of global concrete adopts it, it could capture 100 million tons of CO2, create 5 million jobs, and build 1 trillion cubic meters sustainably, per expert forecasts. It's building a climate solution. Last question, how can you support this? Use eco-materials, back green construction, or share this video. Every block helps. Would you live in a carbon-negative building? Comment below, like the video, and subscribe for more eco-innovation.